We're going to start looking at linear systems by looking at finding the solution to a linear system with graphing before we move on to algebra and the two methods that we'll have there. So we're going to start with our definition of a linear system. All a linear system refers to is when we have two or more equations that are being considered at the same time. So two things that would be plotted on the same graph to see how they interact. In terms of a solution to a linear system, that is the point where the lines meet. It's the point of intersection. I will often abbreviate that as POI just to save some space. So the point of intersection is the solution. That's the point where it meets. So it'll always be given as the coordinates in XY form. So for an example here, we have a fitness club charges a monthly fee of $25 plus $5 per visit. Workout Plus charges a monthly fee of $35 plus $3 per visit. We want to write an equation to model the cost for each club, and then we're going to graph those to determine when both clubs cost the same amount. So our Fitness Plus club, we'll number that equation 1, and the other Fitness Club will be number 1, Workout Plus will be number 2. So equation 1 here, we're going to have that the cost equals, and now it's $25 plus $5 a visit. So it's $25 a month plus $5 for each visit. So C equals 25 plus 5V. It's $25 a month plus our $5 a visit. And this is what would cost in 1 month. The Fitness Plus Club, number 2, the cost there is $35 plus $3 per visit. So 35 plus 3V. So there's our two equations. They're in slope y-intercept form. We have our y-intercepts as the first number and our slopes as the second number with the V. So I'll plot each one. Use a couple different colors here. I'm going to use red for the first equation and blue for the second one. I'll go to my graph here and I'll plot the y-intercept and then I'll use the slope. So 25 would be here, and then I'm going to use a slope of 5. So that's the same as 5 over 1. So I go up 5 and over 1 on the value. Up 5 and over 1. And that's not right. So if I make a mistake like that, I can put a little X through those points. I should have went up 5 and over 1. So that one was right, sorry. The second one's wrong. Up 5 over 1. That second point is wrong. So I'm going to put my dot there. There we go. That looks a little better. Up 5 over 1. Up 5 over 1. I got a few points there. They're lined up in a straight line. Again, why it's important to do a few points just to make sure you didn't make a mistake. They should all line up. We know this is a linear type equation. And so now I'll connect the dots and make a nice pretty line. I'll extend that a little bit because I'm not sure where they're going to intersect. So there's my first line. And again, if you're using things like pen and that, you can just put an X through. If you're using pencil, you can erase it. In the case of the next line, 35 and then 3 is our slope. So we'll start at 35. Now we're going to go up 3 and over 1. So that's going to be about 38. That's going to be approximately here. I'm just going to put a light dot. I'm going to see if I can get one that nicely lines up on one of the grid lines so that I can make a nicer graph. It is harder to do these graphs. This is why we're going to learn about the algebra methods in the coming lessons, because they're a little more accurate. So 38. The next one would be 41. It's going to be about right here. This would be about 44. Right here. 47 is going to be about right here. Just under half way up. And then 50. There we go, there's 50. So that one does work out nice. So I'm going to use those 2 points to make my line, just because I know that I'm on the right spot exactly. You can see some of my points were pretty good. That first one might be a little high. So that can really skew your lines, which is one of the reasons why we're not always going to be fans of graphing unless we're using technology, because we're not going to get exact points. Even here, these lines look like they might be slightly off in that point, but it is going to be at 5 visits that the costs are the same. We would want to state something like that with this problem. In the next example, what I have is just a couple of equations, and we're going to graph both of those on the XY axis. It does work, and this all works if we have positive and negative values. In the cases that I'm working with, just for the sake of fitting on the page, I just picked positive values. But our values here, we have the point of intersection of y equals 10. So I could graph that equation. That's just a horizontal line at 10. So I'm going to make that one red. So y is always equal to 10. So I'll just go straight across here. And then I'm going to graph this next one. Now this next one is in a standard form, which isn't as useful. So we need to actually do some calculations here to figure out the slope y-intercept to make it a little more useful for graphing. So I'll rearrange it here. I'm going to move the -3 over to the other side. That's going to become +3. So I've added +3 to both sides. And now I'm going to divide by the 4. 16 plus 3x over 4. And again, when I divide these two terms by the 4, each individual term can be rewritten as a fraction over 4. And so I can simplify that down to y equals 4 plus 3 over 4x. So now I have a slope y-intercept form. I can graph that pretty easy. I'll do that one in the blue. So go here, start at 4. And now my rise over run is 3 over 4, so I'm going up 1, 2, 3, over 1, 2, 3, 4, up 1, 2, 3, over 4, and that's all I'm going to fit on my graph, but that's perfect because that gives me a point of intersection at that line. So here the point of intersection hits at 8 and 10, so I do a little therefore, the POI is 8 and 10. So if it's a word problem, like above, we're going to make some statement to answer the question. However, if it's just looking for the point of intersection, we can just say the POI is, and then list that point.